Hey, this is Mr. Compier, and since you've already been in my classroom for 2 years, this video is about digital electronics, otherwise known as DE. So this is part of the whole STEM career pathway, and you should have already taken IED or CAD. You're currently in POE, and you're planning on doing digital electronics. So if you're not familiar with it from what I've said before, this is the third year dual credit course, meaning you can get college credit as long as you do the Ivy Tech application. And we focus on small scale electronics, specifically electrical engineering. This course is also very heavy in math and logic because you have to understand how the flow of the circuit works, and you have to complete POE before you do this. And I also want to note too, this is not construction wiring. This is small scale electronics. So like the other courses, there are 4 units. Unit 1 is Foundations in Electronics. And we basically review the electrical stuff we talked about in POE, as well as other courses. We talk about electrical theory, Ohm's law, power law, Kirchhoff's law, and many more things. We learn how to do the reading and performing measurements within a circuit, do some real world building with soldering, and briefly covered the other topics in the course too. After that is combinational logic, where we spend most of our time. Basically, you've got a series of inputs and you got some outputs. You flip through your switches to see what it's supposed to do and if it matches the requirements for your project. This can be based on a word problem, a truth table, or whatever. We'll learn about it as we progress, including ways to simplify it so that way we wire less stuff. As you can see with this picture, it's a mess. You will have to learn how to troubleshoot as you go along the way, because if you try to do it all at once and test it and it doesn't work, you're going to have a lot of work ahead of you. Unit 3 is sequential logic. So Unit 2 uses the switches. Unit 3 is kind of like an autonomous circuit where it does its own thing, but you can still have some input into it. These are primarily used to make counting systems, including an NCAA shot clock. Unit 4 is called Controlling Real-World Systems, and this is where we talk about state machines, both the concept of it in programming and the physical version of it, which is what we do. And we learn how to program microcontrollers, time permitting. We also do some reverse engineering with electrical circuits, and we try to recreate it in Arduino. For example, this picture shows a circuit of Simon Says. So, you've already been with me for 2 years, maybe even 3. I need to make sure that your math skills and your logic is very strong still, and that you are still creative and curious about the topics we have. But if you have questions, talk to me in class, email me, or your guidance counselor to get more information.